Thank you for joining this lesson. We're going to look at a question in section 1. We are told that a chord AB, whose length is 8 centimeters, subtends an angle APB, which is equal to 60 degrees at the circumference of a circle. Calculate to 4 significant figures. Part A, the perpendicular distance from the center of the circle to the chord, and part B, the radius of the circle. Remember to subscribe to this channel and to also share the link with your friends. Let me begin by drawing a sketch of this circle, then the chord, sorry for all right, this is my center. Anyway, it's just a sketch. If this is our center O, we should know that there is a chord which is 8 centimeters. The chord is AB. Then now this chord produces an angle at point P, such that standing at this point to point P, it is 60 degrees. There is an angle of 60 degrees at this point. Now, that is at the circumference. It should be noted that we're going to apply also the knowledge on angle properties of a circle, such that we know at the circumference and at the center, if we produce angles, there is a relationship between those two angles. And the relationship is that the angle at the center is twice the one at the circumference, 120 degrees. So we can divide these furthermore now and agree with me that now if we perpendicularly bisect 120, we will also bisect the chord into 4 centimeters and 4 centimeters, and we are having now 60 degrees and 60 degrees. Therefore, I can deal with a triangle now. If I call this point M, OBM, such that I got 60 and 4. And the first thing to calculate is the perpendicular distance from the center of the circle to where the chord is, distance OM. Therefore, I'm going to apply trigonometry, because this is a 60 degrees and the adjacent length is not known, yet we have the opposite length to the same angle. We can use tangent and say the tan of 60 degrees should be provided by opposite 4 centimeters out of the adjacent length OM, which is not known. Therefore, the adjacent length OM can only be given by 4 out of the tangent of 60. 4 out of tan 60, and this can be operated using the calculator. So using my calculator, 4 out of tan 60 is going to be 2.309, and to 4 significant figures, 2.309 is going to be very accurate. That is to 4 significant figures. In part B, we need the radius. For us to get radius, now that we have a length and a length, we can even apply Pythagoras theorem. But allow me continue applying trigonometry, in which case I will say with 60 degrees and the opposite length, I can even say that the sine of 60 is given by opposite out of their known hypotenuse, and the hypotenuse in this case now becomes our radius. So for 60, for this triangle, in other words, the hypotenuse is also our radius. So we can get R by simply taking 4 out of the sine of 60 degrees. So the radius to 4 significant figures will be given by 4 out of sine 60. This is going to be 4.6188. So 19 to make it 4SF.